We are Pisces ClimatePro, a team of experts in artificial intelligence and machine learning applications to water and climate. Casey Brown is a specialist in climate risk management for water. Manulal is our PI and the director of the Columbia Water Centre. Scott Steinschneider at Cornell is an expert in applying AI to hydrology and climate. And Ken Kunkel is the lead scientist for the National Climate Assessment. My name's Alexa Bruce and I am a former consultant to the UK National Infrastructure Commission. Our goal is to create an AI-based platform that water managers use to anticipate and mitigate their climate risks. We are facing challenging times from a water perspective. As we all know, our climate is changing at an unprecedented rate. And we're experiencing the impact of these changes right now. Over the last 40 years, the US saw $263 billion climate disasters, with total cumulative costs of almost $2 trillion. And this is projected to increase. The most recent National Climate Assessment estimated the annual damages from water disasters would reach $450 billion per year. This is not only a future problem, it's a present danger. Right now in the American West, 78% of the region is in drought. Lake Mead is at its lowest level in recorded history, and there's no end in sight. Throughout the West, water managers wonder, should I ration water? This may save the water they need to make it through the drought, but reduces their revenues. They're also wondering if this is the new normal, and should they invest in billions in new water sources like desalination? With climate change, water managers don't know what to expect in the future, whether it's the next 6 months or the next 6 decades. In the US, our water supplies depend on 50,000 independent water utilities making these decisions. Many are small and underfunded, of which countless are unprepared for climate change, leaving businesses and people exposed, as we recently saw in Texas. At Pisces, we see a clear opportunity to use artificial intelligence and machine learning to identify and reduce America's water risk and transform this new and growing market of climate risk management. ClimatePro is a scalable online platform that uses AI innovations to integrate climate observations and forecasts, hydrologic simulation, and model emulation, providing users with early warnings, new planning capability, and real-time risk estimates so they can anticipate and mitigate their water-related risk. These resources will have applications in several settings and across industries. Let's look at a specific example. Here we have a water utility in the western United States that is caught in the midst of a mega drought. They have to make critical planning decisions which will have large consequences for the communities they serve. In the short term, how will they allocate water over the next 6 months? If the drought continues or gets worse, they will need to impose restrictions on water use today to secure the water they need for the rest of the season. But imposing restrictions now would reduce revenues, putting financial strain on an already debt-laden utility. But if conditions improve, then this is unnecessary. They need an understanding of what the climate will look like over the next 6 months and what this means for their specific water system. They also face a critical long-term planning decision. Do they need to invest billions of dollars in new sources of water in order to continue to provide reliable water for their customers? What kind of conditions can they expect 20 years from now? If persistent drought is the new normal, then their current water supplies will be insufficient to meet future demand. But if this is an unusual, rare event, then multi-billion-dollar capacity expansion projects would be a waste of public resources, with consequences for households who will see a hike in their water rates for years to come. Right now, utilities have little understanding of what to expect in the future, leading to paralysis. That's why we've developed Pisces ClimatePro. ClimatePro will answer the questions utilities have in the short term and the long term, so they can take immediate actions to build resilient and thriving communities. Right now, to answer these questions, a water planner must procure a consultant or several consultants to process climate model projections, develop a hydrologic model and a model of their system to provide them with the information they need. This is typically a year-long process or longer, and too expensive for all but the largest utilities. Our tools will automate this process from end to end, using machine learning to automate model building and calibration. With the system in place, we can provide locally tailored forecasts that managers can use for operational decisions, improving their ability to manage shocks like the current drought. The long-term analysis capability will be used by planners to answer their questions and create compelling investment plans that gain public support and funding. Overall, this results in a water utility that's prepared for the climate challenges ahead. And the technology allows us to offer this online and accessible for all utilities, including the small and disadvantaged. To make this all possible, we are innovating physics-informed machine learning approaches generally, and with a focus on explicit modelling of uncertainty in our 3 components. Our first component is the local climate forecasts. We have developed a novel machine learning algorithm that integrates Bayesian hidden Markov model with artificial neural networks. This allows us to capture the fast-moving features, like how much will it rain in the next month, with slow-moving features that got us here, which are the ocean temperatures and atmospheric circulation patterns. In addition, our tools can be used for prediction of other environmental variables, such as forest fires, and we are exploring how our algorithms, which model patterns in space and time, might be used for medical diagnostics when applied to medical imaging. Our forecasts serve as inputs to the next component, our hydrologic simulation tool. We have validated the long short-term memory model, an artificial intelligence algorithm, for hydrologic prediction. This included out-of-sample validation for new climate conditions, which is a breakthrough in hydrology. We are continuing to advance physics-informed machine learning by mapping the physical constraints and the topology of river networks into the model architecture. The integration of physics with the AI model is a pathway to interpretable and trustworthy AI. This serves as the basis for improved hydrologic prediction and projection, which will then extend to groundwater, water quality, and flood prediction. Hydrologic predictions then flow into the water system model, or digital twin if you like. This is the key piece that integrates local water system data. Emulation allows us to greatly reduce the time required to create a local model. This is further enhanced by incorporating federated learning to enable model improvement through sharing of demand and system data. In total, this represents unprecedented modelling capability at local scales. Utilities are not the only ones vulnerable, and we anticipate a reckoning in the private sector as well. We are partnering with these companies and more to explore these new use cases. These include disclosing and reducing business risk, designing new financial products that hedge climate risk, or inventing new investment products that limit investors' exposure to climate risk. Our long-range plan is to continue to grow our water utility business, starting with Western US applications, and then developing prototypes for private sector applications, following deeper customer discovery and prototyping. This is our 2-year roadmap. With Phase 2 NSF funding, we will kick off our product market fit with water utilities. In year 1, we will build out our team, finalise our business model and IP strategy, and complete the dry or Western US prototype. By the end of year 2, we will have completed the wet or Eastern US prototype, carrying out beta testing of the software, raising funds, including possible SBIR funding, and go to market with a professional build that's ready to reduce America's water risk. Thank you for listening.